Welcome, dear students, to another class of BCH 308, Food Biochemistry. The topic for today is peptic substances. What will be our learning objectives? At the end of this lecture, you should be able to define peptic substances, describe their structure and classifications, explain gelation mechanisms, identify sources and application, relate changes to fruit ripening. Before we proceed, let us look at the concept of peptic substances. Peptic substances are plant-derived complex polysaccharides that play a major role in cell wall structure, fruit firmness, food texture, and gel formation. They are especially important in fruit-based products. You can see the picture before you of ripe and unripe plantain. Of course, you know from experience that the unripe is hard, while the ripe is soft. Now, that factor is a function of the peptic substances that is present in the unripe and ripe variety of the banana. What are the sources of pectin? The major sources include citrus peels, that's peel of fruits. Many local fruits have them, of course, including guava and mango. Their industrial importance is the value addition they render to food products. The basic units of the peptic substance is galacturonic acid, linked in the alpha-1,4 glycosidic bond linkage. To form a repeating structure of galacturonic acid complex. The structure may be esterified by the addition of methoxy group or cross-linked with ions as indicated in the diagram before you. Now, how are the peptic substances classified? They are classified into three groups as protopectin, pectin, and pectic acid. The protopectin are insoluble. They are found in ripe fruits, as seen a few minutes ago in the case of the ripe and unripe plantain or banana. They are responsible for the firmness we see in unripe fruits. Pectin, on the other hand, they are soluble, partially esterified, and these are the molar parts that forms gels. The pectic acid is fully deesterified and does not gel easily. Now, during ripening, the protopectin is converted to pectin. Let's look at the chemical properties of pectic substances. We start by considering their degree of esterification. I must mention to you here that we have high methoxyl pectin and low methoxyl pectin. Now, when the esterification or degree of esterification is greater than 50%, the molecule is referred to as high methoxyl pectin. It will require sugar, high level of sugar, and low pH for gelation. On the other hand, low methoxypectin have degree of esterification less than 50%, and it requires calcium ion for gelation. What could be the factors that can affect the functionality of pectins? These known factors are for pH, that is alkalinity, sugar concentration, temperature, and ionic strength. Now we'll consider each of those factors in turns or one after the other. For pH, it controls the ionization of carboxyl group in pectin. For low pH, that is between 2 to 3.5, the carboxyl groups become protonated. As a result, there is reduced electrostatic repulsion, and then chains come closer together to form gel. On the other hand, for high pH, you have more negative charges, and of course chain will repel each other, and gel formation is inhibited. How does sugar concentration affect pectin? We know that sugar competes for water, and this will reduce the water availability and lowers water activity. When this occurs, it promotes interaction between pectin chain. Enhances hydrogen bonding and hydrophobic interaction, which leads to a very strong gel formation. Now, for typical requirements, high methoxyl pectin needs 55 to 65% of sugar, while low sugar case, there will be no or weak gel formation. So, before applying sugar for or into your pectin, you should know two things. Are you using high methoxyl pectin or low methoxyl pectin? Now, temperature also affects solubility as well as molecular mobility. Now, what could be the effect of heat? One, it dissolves pectin and ensures uniform distribution. Cooling of pectin promotes network formation, that is gelation, and stabilizes gel structure. Excessive heat or excess heat, on the other hand, can degrade pectin and result in weaker gels. Now, let me explain what we mean by gel in food. You must have seen what we call pap, the common pap, made from cornstarch. Now, when you boil water and add to it, it becomes thickened as a result of gelling. However, when the water is in excess, the gel will again lose its structure. So what I want you to understand here is the formation of gel in food as a result of these pectic substances. They help food to gel and maintain structure. Let's look at how ionic strength or mineral and salt affect pectin, especially important for low methoxyl pectin. Calcium, for example, forms bridge between pectin chains, creates strong gels. High ionic strength, that is excess salt, can disrupt interaction, which may lead to weak gel formation. The picture you see here is the gelation mechanism. I mentioned to you earlier that high methoxyl pectin requires sugar and low acidity. The mechanism involves hydrogen bonding, plus hydrophobic interactions. That is what gives the gel or lead to the gel formation that you see. So for high methoxypectin, the environment must be acidic and sugary. On the other hand, low methoxypectin requires calcium ion to be able to cross-link with carboxyl ion to form gel. Now, while explaining, I must have mentioned the functional role of pectin in food. Yes, I mentioned jelly agents. They function as jelly agents. They function as thickener, stabilizers, water binding agents, and fat replacers. These are qualities that are desirable in food depending on the food you are actually preparing. And in what products do you normally find is pectin applicable? We have them applied in jams and jellies, yogurts, fruit juices, and confectionaries. The biochemical changes include the enzyme pectinase breaking down protopectin, leading to softening or increased solubility of pectin. That is, as the fruit is ripening, the enzyme pectinases or pectinase will break down protopectin, leading to softening and increased solubility of the produce. How do they interact in food system? The sugar form gels with pectin. The acid controls pH, and protein provides stability. Now, what effects do they have on food quality? Now, the effect of this pectin in food improve they help to improve texture, mouthfeel, and water retention of the food item. As mentioned earlier, industrial applications include jam and jelly production, dairy stabilization, and bakery fillings. Non-food uses include pharmaceuticals and cosmetics. Yes, They are used in cosmetics, pharmaceuticals, and in the food industries. Peptic substances in the food industry have this particular slide. I'm repeating it. I spoke to it a few minutes ago. Now, this condition of sugar and acid allow the pectin to get closer, form three-dimensional network, trap water, and gel. Gelation occurs as a result of water trapping. Please note, it's important. Of course, you know now, if you drink too much water, your tummy will be bloated. That's exactly the same thing that happens. Well, for industrial importance, jam and jelly, they controls texture, that is spreadability, firmness, prevents syneresis, which is water separation, ensures consistent product quality. Dairy stabilization. Pectin acts as a stabilizer and thickener in many dairy products. The mechanism include interaction with milk proteins to form a protective layer around protein molecules, and therefore prevents aggregation and sedimentation. They are applied in drinks, yogurt drinks, flavored milk, acidified dairy beverages. Of course, the benefits: they improve texture and mouthfeel, prevent phase separation, enhance product stability during storage. They are also used to thicken and stabilize fruit fillings in baked products. So far, we have looked at pectic substances and their structure as polysaccharide. We mentioned, or we have learned, that pectic substances are critical for texture and for gel formation in food, and that their function depends on the degree of esterification and environment. And now we have also learned that they are widely used in the food and feed industries. As usual, I have a set of self-assessment questions for you to tease yourself with. In case of any difficulty, as usual, take note of it, so when we meet physically, we'll go to treat or discuss the issue together. Thank you once again for listening, and thanks for watching. Have a good day ahead.